In this video, I'm going to talk about processing multi-level XML files. XML files sometimes could be complex to process because of multi-levels. For example, XML file contains multiple elements, element, under element, under element, like that. If the structure of the XML document is complex, the XML source connection in the data flow task will give multiple outputs for that XML file. In this video, we will see how to denormalize the multi-level XML file and write as a single row for a logical node. Let me show you what I'm talking about. For this example, we are going to work with this XML file. If you see the XML structure, this has the top level node, bookstore, and it contains books. And there are two books. This is one book and this is another book. As you can see, this is one level and this node second level. This is third level. Okay, and publication is fourth level. So there are four levels of the nodes. If we give this XML file to the XML source connection in the data flow task, the output will be like 4 outputs from the XML source connection. Okay, but we really want one output. Okay, one row, all the book related information in one row, so that our it could be like our table structure, SQL Server table structure. It just contains one row, the book related all the elements. For example, I have the SQL Server table structure is like this. Okay, in fact, I created the SQL Server table. Let me show you that. Okay, here you can see the denormalized bookstore table. It contains book style, author first name, last name, award, publication first name, last name, price of the book, editor first name, last name, everything in one row. Okay, and but here if you see some portion of the information is in one level and other piece of information in another level. It's like that. So if I give this XML file, I'm going to get multiple outputs. So I need to denormalize, put everything in one row and insert that. So how to process this XML file and insert the data into this table? There are a couple of approaches how you can load this XML file into the table. Let us write that down. In this video, I'm going to talk about 3 approaches, and there could be many. Approach 1, we'll use merge, join, and sort tasks to combine the book node in the XML file and write the book related information in the SQL Server table. Okay, so this is what our first approach. So let us look into first approach. Let's create a package and name the package as process multi levels. Okay, our first approach is going to use data flow task. Approach 1. Okay, so first we don't need variables. Let's close that unnecessarily. It is popping up. Drag the XML source. Okay, we need to give the XML file, and this is what the XML file we created for this example. Okay, and this is what that XML file is. and we can generate the XSLT for this XML file. Okay, it generated columns. It says we cannot use more than 255. You need to define that in XSLT because SSIS generated the XSLT file. It doesn't generate very well, but still we need to go and do some minor changes. But for this example, we don't expect more than 50 bytes or 60 bytes, so this is fine. You can ignore this error. So it's warning, not error. Okay, now if you see the output, there are 4 structures. Okay, but we really wanted everything in one structure so that we can just directly dump that into the SQL Server table, but it doesn't do that way. What we needed to do is, okay, let it generate four outputs. Close it, say okay, and we needed to merge all the four outputs into one. So for that we need to use merge join. Okay, we need to merge that. Let me show you that. We need to merge author with edition, with book, and with publication. Okay, so we'll be using probably 3 merge joins, and probably we'll be using 1 sort. Okay, here one more thing we need to do, without which we cannot proceed. Go to the advanced editor, publication. For every output is sorted, so otherwise we need to sort it. Let's assume that it is sorted. Say true for every output. Okay, and also go here, and the top level in our structure is bookstore. Under that, book. Okay, so here book output columns. Okay, this is, change this to sort key 1 because it's going to sort for us. So make it as 1. Okay, and also editor, change this to 1. Similarly, author. For the author, as you can see here, author contains the book ID as well as the author ID. Okay, because these need to be joined with this node. So this node and this node, there is a link. That is why book ID in book node and book ID in author node, there will be link. And there is one more link called author ID. That author ID in this node will make a link to this publication. Then only the publication node can make a link to the author. Okay, so that is why you see the 2 IDs here. So book ID will be 1. Okay, and author ID will be 2. And here this will be 1. Okay, we need to do this, otherwise the merge join will complain that this is not sorted. Go and sort it. Okay, what you need to make sure the is sorted is true and the author ID starts from 1. The ID column starts with 1. Okay, we'll make sure for author node it is true. Book contains 1, author contains 2. Editor node is sorted true. Book ID contains 1. Fine. Okay, we made sure that. Now we need to join. The merge join accepts just two input sources. Okay, if it accepts multiple, then we can give all the four outputs to one merge join, but it doesn't do that way. It is a normal merge join and it accepts just two. Okay, so we are going to, okay, first we will merge this with this, book with author. Okay, book, this will be our left input, and we will merge with author or editor, anything is fine. Okay, here we need to select the style, price, and this is editor, I guess, so make it as a editor first name because we have the author first name, publication first name. So in order to avoid the confusion, let us select the column and rename it as editor first name and editor last name. Okay, let us select the book ID. Okay, so here we need to select if it is going to be a inner join or left outer join or full outer join. Okay, so here we are joining book with editor. Okay, so if you look at the example, book with editor. Okay, but this book doesn't have editor. Okay, this book has editor. So in this case, our left hand side table will be book and right hand side table will be editor. So we need to use left outer join. If we use inner join, then we won't get this book. Okay, so we have to select left outer join. So we merged two outputs. Okay, we need to merge with the third output with, okay, let us create one more merge join, and we may be needing one more, so let us drag it. So here book, editor, and there is author and publication. So here this will be author. Okay, so we are merging the output of book and editor, join of book and editor with author. Okay, this will be author. Here we have one author and here we have one author. Okay, we can say inner join or left outer join, both should work fine, but we'll say inner join. We'll select all the columns and this will be author first name and author last name. Author last name. Okay, we are done with merging book, edit, and author. So we need to merge with publication. Okay, but the problem with publication is, okay, you'll see that. Let us merge that and you will see the problem. Okay, publication and merge right output. Okay, see that is sorted property must be set to true, because this is not XML source. We cannot set that. We need to have the sorted, because we are merging and kept on merging the sources. So we need to have a sort function here between this merge and this merge to sort the output and give the sorted output to this. Then we can merge with the publication. Okay, so delete that, drag the sort, give the output to the sort, open that. So we are going to sort the author ID. Because publication has the key, the ID, which is author ID. So we need to have the output with the author ID. So that is fine. As you can see that. Okay, here we need to decide whether it's going to be inner join or the left outer join. Okay, so publication, here we have publication, but for this book we don't have that, so it should be left outer join. So this combination, this output should be left outer join output. Okay, as you can see, author ID is automatically mapped. Okay, we'll select everything other than the author ID, because we don't need the author ID in the output. All we need is everything other than IDs. Okay, now we have the style, price, editor first name, last name, author first name, last name, and this should be what this publication first name and last name. Okay, okay, now all we need to is just get the destination connection and dump the rows. That's it. Give this output connection, double click that. We don't have a connection here, so we need to define one. So I have created a table as I have shown it earlier. This is a table, denormalized table of the book. So we are going to make a connection to the table. This is the table, and mappings, award. Oh, somewhere we missed the award. We'll see where we missed that, and everything else is mapped. Okay, where is that award node? Award node is in author. So when we are merging with author, probably we might have missed the award. Okay, that's pretty much it. If you run the package, then it should create 2 rows, as you might have seen. Okay, yeah, it created 2 rows. Let's go and check the 2 rows. Okay, autobiography, style is autobiography, first name is Joe, last name is Bob. Okay, and award is Trenton Literary some shit, as we can see that here. Okay, and price is 55. and publication, there is no publication node, that's why it is null, and there is no editor node. Okay, so there is no publication, but in the second book we have the publication here, and even the editor for the second book. That is why the second book has that information, not for the first book. Okay, second book doesn't have the award. In the author node there is no award element, but in the first book there is award. Okay, now we have denormalized this entire structure. We made it as a flat and we inserted into the SQL Server table. Okay, this is one approach. As you can see, there are many things we did here. We merged book with editor, and after that the output we merged with author, and we sorted that, and finally we merged with publication. We did a lot of circus here. Okay, this could be little slow if the input XML file is huge. Okay, if we run the XML, if we have the large XML file, then this process will be a little slower. Probably you may have to check that, but this is one approach. Okay, we will see the second approach. In the second approach, what we do, we collect the 4 outputs from the XML source connection. We'll collect the 4 outputs from the XML source connection and store it in a table. Okay, before running the package, we need to create 4 tables to collect 4 outputs from XML source connection. After that, we will use we'll use data flow task to join the data from the 4 tables and insert into the final denormalized table. Okay, we'll look into that. For this, first we need 2 data flow tasks. Okay, what we'll do, we'll create a sequence container and we'll put those 2 data flow tasks in that sequence container, and we name it as approach 2. Okay, here we'll give the XML file. Okay, we have the DST here. Okay, now it returns the 4 outputs: publication, author, editor and book. Okay, which is fine. We'll collect all those 4 outputs in tables. So we need 4 connections. Oh, by the way, I created the 4 tables, as you can see here, to author, book, editor and publication. I created the 4 tables. I have given the SQL query here, so if you are trying on your own, probably you can use this. Okay, let us collect the book node information into this, and we will store it in book table, straight book table. Okay, similarly author in author table. Okay, like that. Do that for editor and publication. Okay, we collected all the 4 outputs straight into the tables. Save this package. Now if I run this, okay, let us see if there is any data in the there is no data. Okay, we are starting from clean slate. If I execute this particular task, then it should insert the rows into the 4 tables. Okay, fine. Now all I need to do is use a SQL join the 4 tables and write the output into denormalized table. Okay, I have created the SQL query. Here you can see that this is the SQL query which just joins the 4 tables: book, author, editor and publication. Copy this SQL query, go to the second data flow task, and here we are going to use the OIDB connection to get the data by using the join condition and write the data into the denormalized table. Okay, so here our input will be SQL query. Okay, this joins the 4 tables and gets the data, and connected. The output will be our denormalized table. So everything should map: author first name, the last name, okay, we map the columns. So now if I run this task, the second data flow task, it should join the 4 tables, the information in the 4 tables, and write the information into the output denormalized table. Okay, the package ran successfully. If you go data flow task, 2 rows are inserted into the loaded into the table. Okay, if I run this query again, you will see 2 more records. Okay, this is same as the first one, and the 4th record is same as second one, because this is our second approach. Okay, now we are going to look into the third approach. In the third approach, we are going to use the XSLT operation. In the in the XSLT operation, we need to convert, what we can do is we can convert the XML file, the input XML file into a flat XML file, in the sense that there will be only two structures. So in the XML source connection output, you'll have just two outputs in the XML source connection. So we can directly map it to the output table. Okay, let us write that down, our third approach. Approach 3, we will use XSLT operation to denormalize or make it flat. Denormalize the XML file and use the flat XML file for the data flow task. So we will straight away load the flat XML file into the table. This would be faster. This is better than okay. So for this, we need to use the XML task to use the XSLT operation. Here we will use XSLT operation, and we are going to convert the input, the complex input structure, into much better flat structure. Okay, for that we need to, this is the XSL file. Okay, I created the XSL file for this XML. Okay, let me show you that XSL file. This is the XSL file that I created for this XML file. Okay, if I use this XSL file, this is the XSL file to convert the complex multi-level XML structure, XML document, into pretty simple flat XML document. You will see the output. You'll come to know what this XSL would have been doing. So here we will create denormalized XML file .xml. Okay, we are going to use XSLT operation, and we are going to apply this XSL against this multi-level XML file, and we are converting that into flat XML file. Okay, if I run this XML task, you will see it has created new structure, new XML file, denormalized XML file. Okay, let us open that and see. As you can see here, this book, there are again, this is the data in this file, the denormalized XML file is same as this, but it's denormalized. As you can see, all the elements are directly under this node, but whereas here, if you see, style is here as attribute, and author is a sub-element, and first name is sub-element of author. Here what I have said in the XSL file, create everything and directly on book node. Okay, style, even the attributes, everything. Okay, so style one node and author first name, okay, author last name, and publication first name, award, price, everything. Now if I give this XML file to the XML source connection, it will give just one output. Okay, just this structure. I can directly take this and load it in the table, which would be much faster than previous two approaches that I said. Okay, probably we will keep this in a sequence container. We'll use one data flow task. We have denormalized XML file. We can give that XML file to this data flow task. This is the denormalized XML file. So if we give that, okay, we can generate XSLT using SSIS. It generated. Ignore this warning, that is fine. As okay, there is only just one structure. You can directly load that because we denormalized in the XML level itself. Okay, we can directly load that information into the SQL Server table. So here I'm going to say denormalized table. In the mapping, it's going to map automatically. I hope so. Yeah, because names are same. Okay, if I run this task, then it will insert into the, yeah, it inserted into the output table. Let me see if it inserted. If I run this, yeah. Okay, the third approach is much more faster. If the input file, XML file is huge, large, if you are processing large XML files, then probably this would be much faster than previous two approaches. Okay, I hope you got how to deal with multi-level XML files, much complex XML files.